All right, so we're on to infancy this week. And you'll notice in the lecture notes and the way I have the slideshows this week, it's in two kind of sets because the textbook that I used last year had it broken down into two chapters, but Feldman has it all in one chapter. It's really condensed, lots of information. But I decided to continue to keep it in these sort of categories of physical and cognitive development, and then our next lecture will be on social and emotional development. So we're looking at physical and cognitive development. We have some basic growth patterns. Now, these are really basic, sort of predictable patterns that we expect to see in a typically developing infant. Some babies skip stages, some babies are slightly delayed. There's this sort of wide window that's deemed acceptable for normal development. When you fall outside the window and you're like, why isn't my baby sitting up yet? Why isn't my baby standing or walking yet? It's a pretty wide window, and until you're really outside it, and that's when the parent or the pediatrician says, okay, what's going on? Is this now officially a developmental delay or not? But I know the textbook will give you sort of these ranges, these parameters for when you can expect and those are based on averages. So what's the average age that a baby walks is about 13 months or 12 and a half months or whatever your textbook says, but that's just the average. Right, so some babies walk at 9 months, some closer to 18 months. Once you start getting outside 18 months, and if they're not even using furniture for supports, then you wonder, okay, what's going on? Does he have weak muscle tone? Are there other developmental things going on, maybe cognitively? And then you go to a specialist and get him checked. So what we're going to talk about today is those basic growth patterns. Review neural activity and the basic brain structures. It's totally basic review from Psych 100. I'm not going to go over it too long. I expect you to brush up on that on your own. What the reflexes are that infants are born with. Difference between gross motor and fine motor skills. A little tiny bit about sensation and perception. And then we'll get into Piaget's concepts and his first stage here of development called the sensory motor stage with the substages. Okay, so there is Quentin. Let's see, how old is he here? He's about 4 months old, and he was a 10-pound baby, so he had a big head. Okay, and he can't support his body yet. They have these wonderful chairs called the Bumbo chair. Although I just read that they got recalled. Did you read about that? The Bumbo chair got recalled because too many parents were setting these chairs on top of tables. Okay, hello, like the baby's going to eat dinner with us, and so they put that's obviously not safe. You're supposed to put it down on the floor like this. They're kind of cool because he can't go anywhere. You have to monitor an infant. You can't just leave an infant alone. You have to monitor them. And because you don't know when that day is going to be when they start to scoot, when they start to be on the move. You have them on their play mat laying on their back. I remember the first time my older son, I was around the corner working on something, kind of walking back and forth and back and forth. And I was maybe gone, maybe didn't look back for a couple of minutes, and he had moved about 4 or 5 feet. He had scooted all with the mat. The whole mat had gone with him, and because he had rolled over. I didn't even know he could roll over. So I didn't get to see the first rollover, and he scooted. So you really have to watch an infant all the time. You cannot just leave them alone. And being in a chair like this does not say that he's, in any kind of, he's not strapped in or anything. But look how big his head still was. He was a big kid, big, chubby kiddo. But the growth pattern in the first 2 years is called the cephalocaudal growth from the head down. So they're born with this very large head. It's disproportionate to the rest of their body. because all the brain structures are there. They don't have, their neurons aren't communicating yet. They're just born with basic reflexes, but they're really disproportionate. They can't hold up their head very well, and they grow into their head. So even in sitting in the Bumbo chair here, he can hold his head up. He's 4 months old. He's looking around. He's real happy. He was watching whatever Camden was playing with. And but after about maybe 30 minutes, that was pretty good that he could be in this activity for 30 minutes. He would get fatigued, and then he'd get frustrated, and he'd start to cry, and it's because his neck was really getting tired. He's holding his head up. So then I'd have to sit him in a bouncer chair or lay him flat on his back or do some tummy time. Okay? You want to do that tummy time so that they strengthen the muscles in the back of their neck. But that has to be monitored. That's super important because their head is so heavy, they drop their head down and mush their face right into their play mat, and they could suffocate. So, or just get really mad. So you want to monitor them in small amounts of tummy time play. Proximodistal growth is growth from the center out. So the first 2 years of life, the head is really big, and they grow from the head down. And that kind of continues through childhood. And then when they hit middle childhood, kind of edging into puberty, what's the first thing to jump in size? Does anybody know? Anybody have kids that are around that 10, 11, 12-year-old age? No one has kids? Their feet, right, shoes. All of a sudden, so then you see these 4th and 5th grade kids with enormous feet that don't match their body. It's really funny. Yeah, my feet, I think, were a size 9, ladies 9 in 6th grade. And I was about 5'2". So, which was tall for a 6th grader, right? I've always been tall, but I'm 5'8" now, so it was definitely not my full height yet, but my feet were nearly their full length, right? And so boys, same thing. And so their hands will grow and their feet will grow. And then the limbs, and especially in boys, they won't grow the center of their chest, does not grow. Their rib cage and their back doesn't expand, their shoulders don't expand until they're in late adolescence, sometimes even in their, age 20, 21. It's kind of like the kid goes off to college. Swear to God, they come back at Thanksgiving and their chest is grown. Maybe it's too much eating and drinking. I don't know, but that's that final stage. So they grow from the center out in late childhood through adolescence. Okay, so the first year of life then, on average in North America, about 20 inches long, 7.5 pounds, and again that's average. You can have a 6-pound baby that thrives and does really well. Once we get less than 5 pounds, we start to worry a little bit about, because they can't really lose too much more weight. You want them, they're going to lose weight within that first 24 hours after birth. I mentioned that last week. They've been soaking in amniotic fluid, for the last 9 months. They've absorbed a lot of fluids. They're really well hydrated at birth. So you don't have to be too worried about them feeding immediately. And they are going to lose weight within that after you give birth and then are checked out from the hospital. They weigh the baby, and the baby will have lost weight. And part of it is the natural fluid that they're peeing and everything. But then they're pooping out that meconium, that tar that they've just been ingesting the amniotic fluid. And so they have lots of big black poops the first 24 hours. So that's losing weight. And then adjustment to feeding takes some time. So that's where if you have only a 5-pound baby, it's a little bit more touch and go because you don't want them to lose like a whole pound, right? I think Camden was 7 pounds, 13 ounces. And when we left the hospital, he was still over 7 pounds, but just barely. I mean, that's a significant percentage of weight loss. Quentin went down to 9-something. I was like, oh, he could lose another pound and still be okay, right? So this adjustment to feeding, It's sort of a two-way process. It's both mother trying to figure it out as well as the baby. In your breast milk, in female's breast milk, the first couple of days there, it's this thin, really nutrient-enriched substance called colostrum. And that's really, really important for the baby's immune system. But the milk hasn't come in until about another day later. And sometimes women will have some issues with engorgement and not being able to, if they have a plugged duct actually in their breast tissue. So the nurses, those of you who want to be nurses, if you work in labor and delivery, there actually are specialists, lactation consultants. That they aren't nurses, they're consultants, but they work with the RNs and come in, and they can bring in a pump to help a woman. But if your baby is, not under 5 pounds, he or she is okay. They're probably okay. If they were born healthy, this is a normal adjustment to feeding. The best way to get any of those plug ducts out is to have the baby try to nurse, to have them work it out. And, you remember in Psych 100 that your pituitary gland is releasing oxytocin that allows for the milk letdown. And what really is triggering that oxytocin from the brain is the baby. So a breast pump is, a suction that fits over the nipple and it, pulls, but it's not a little 8-pound breathing, warm, crying. The crying triggers the mother's brain. Have you ever seen anybody, a baby's crying and mom starts to leak? Yeah, that's like a natural reaction to get your brain going to have the milk let down. So there is this adjustment to feeding period, and then, of course, rapid growth in the first year. What we're really, really having lots of growth in is the brain, of course. But then, the entire body, we're gaining weight and size. So when the baby's going to their well visits, the pediatrician visits, and they go 5 days after birth, and then 2 weeks after birth, and then 4 weeks, and then it goes 2 months. I think is there a 4 month? There's a 4 month, I think, 6 months, and then from there it starts to spread out. If you have a healthy infant, right? If they have some health problems, obviously your visits are going to be different. But there's 3 main measurements that they take. They measure the baby's weight, of course, their length. They're not going to measure them standing up until they're over 2 years old. So they just lay them flat on the examining table and kind of try to stretch them as straight as they can and measure their length. And then the third one, what do they measure? So we've got length, weight, head circumference, right. That's super important because that is measuring for brain development. So they get the little tape measure and they go around the baby's head. And we have this rapid growth. By 2 years, this is real approximate, half their eventual adult height. It's sort of a fun formula, so if they are 3 feet tall on their second birthday, then you can go, oh, okay, well, this child is going to grow to be 6 feet tall. But there are other factors, not just you got a good early start, but something could happen along the way that interacts and maybe you don't reach your full potential. So nutrition is essential, as well as exercising, moving your body, not having injuries or illnesses. All of those things factor in. So it's really a really rough estimate in the 1/5 their adult weight. Okay. Now you look at their brain weight. Okay, so still we're growing in a cephalocaudal pattern. If you're only half your brain or half your height, a quarter of your weight, but your brain weight is at 75% at 2 years old. So you can see how this is still really disproportionate with this big-headed child, right, toddling around. And sometimes they get a big tummy too, and then that goes away by about age 3. Okay, so now, even though their head is disproportionate, it's not like they have a giant head. The head will continue to grow, but the mass is there, the brain, the weight. Okay, so the mass of the brain, 75% at age 2. What is really then wiring up, getting all those neural connections, is the cerebral cortex, which is the outer squishy folds. And why is it squished and folded up into the head? You remember? Why isn't it just smooth like a bowling ball? To increase surface area. Good, right? So you've got how many neurons? Who can remember? How many neurons are you born with? Approximately. Come on. About 100 billion. I just read an article like a couple weeks ago that somebody said 97 billion. I don't know where she came up with that number. Approximately 100 billion. But they are not all communicating with each other, right? But all the shapes are there, and we already have some lateralization going on and specialization in these different lobes, the frontal lobes, the occipital lobes, temporal lobes, and parietal lobes. Okay, so those 4 main areas and 2 hemispheres. So you have 8 lobes in total because it's a mirror image on either side. Okay, so this is what it looks like. So all the structures are there, the exact same shape as they will be at their full adult size, just in smaller form. And, we even already have, response in the visual cortex back here in the occipital lobe. Your frontal cortex is really immature in the newborn. I mean, they can't really control. So you've got your motor cortex on there. They can't really, with intention, control their movements. They certainly can't plan things out, and they don't have self-regulation or impulse control. That's very immature. So those neurons are not yet, they have not created pathways yet. They haven't created synapses. So that's going to come with experience and just flat-out maturation. Remember, brain maturation is just a normal, expected amount of growth that we just expect to see that to happen. And then how other pathways continue to develop depend on their experiences that they're exposed to. Okay. So let's do just a tiny review of your basic brain structures, looking at the neuron. So neurons, remember, are real irregular shaped cell membrane. You've got your cell body there with the nucleus, and what's inside the nucleus? Your DNA, right? So you have your 46 chromosomes in the center there of the nucleus in every neuron. And the neuron parts then, the axon, the dendrites, and the myelin sheath. So the axon is always sending the messages. It's the sending part of the neuron, or we say axon away, axon away. And then the dendrites are always the receivers, and those are those thousands of branches. Okay? And then the axon is covered by a myelin sheath, which speeds up transmission, protects and insulates the axon as well. So at birth, that newborn baby doesn't have a lot of myelin in their brain. And what's really building up and feeding the myelin are the glial cells. And you actually have about 9 times as many glial cells in your brain as you do neurons. So those are super important in nourishing and developing and allowing those neurons to start getting connected with each other. And the baby gets that nourishment through the breast milk. And formula is a pretty decent simulation of breast milk. Certainly better than it was 30, 40 years ago. But obviously, if the mother can breastfeed, that's ideal. There are times when she can't. When are times when she can't breastfeed? If she doesn't have breasts, right? If she's had a mastectomy, that could be. Yeah, Jessica?
The baby can't eat.
Sometimes the baby has, if they were born premature and they can't, if they don't have some of their basic reflexes, if they can't swallow. Yeah, Stephanie?
If she's either on prescription medication or is someone who's doing drugs, if she can't breastfeed, is that transmitted?
Right, if she's on some kind of drugs that could be transmitted through breast milk, certain prescription medications maybe that she has to be on for her own health could then be passed through the breast milk and be put the child in danger. If she's taking illicit drugs, then obviously that would be bad. You know, alcohol is one of those things that can be passed through breast milk. Certainly in lower amounts, and it's not going to cause fetal alcohol syndrome because that's really happening prenatally. But it's also one of those things that we're not really sure if what, you know, safe level there is. I have some friends that would do the pump and dump. They would, you know, drink a glass of wine, hour later, pump and dump, and not feed the baby. You know, I take seizure medications that is absolutely necessary for my health. And on, you know, the little warning bottle, on the warning label on my bottle, it says, you know, ask your doctor if you're pregnant or breastfeeding. And so, of course, they, you know, they said it's okay, you take such a low dose that it won't have any effects on, you know, being transmitted to your baby. But breast milk is really nutritious. It's all the baby needs. The baby does not need to eat anything else. You don't need to give them water. You don't need to give them food. It's all in there. It's all in the breast milk, and that is really key to their brain development. And then, of course, it's going to add fat onto their body. All right. So your neuron basics, then your axons and dendrites. Remember, they don't touch. You have a little gap. And you've got all this network going on throughout the brain, and some of them are happening right at birth because they're reflexes. And you've got the release of neurotransmitters, which are the chemicals that create then these electrical impulses. Right? So you actually have ion exchange in your brain, and that's triggering and causing the release of these chemicals. And some messages are inhibitory, right? But it's really key that you have lots of experiences for the babies so that they continue to produce those neurotransmitters and create the connections. Right? So here's a little picture there just to get your basics, the anatomy of the neuron. Okay? So baby born with all those neurons. They don't have all the dendrites, though, right? So they've got this massive proliferation of dendrites going on right away in the first few years of life. Okay? So this is just a blown-up picture of neurons. So you've got, you know, just a cluster of cells, and you can imagine how at birth it's not organized. You know, a newborn sleeps a lot, right? Now, they don't sleep all in one big spell, unfortunately, because they need to get nourishment. So they will sleep for 2 or 3 hours, 4 if you're really lucky, and then they wake up because they need to eat. Because they only, especially, you know, a newborn, within those first couple of weeks, they can only drink about 1 to 2 ounces of milk. I mean, we're talking like that much out of a bottle, like an inch, 2 inches out of the bottle. And then if they spit up at all, they lose some of it. We used to call it liquid gold. We'd be like, no, you know, he just spit it up. It was liquid gold. It took me all day to make that, you know. And but so you just imagine the calories that, you know, how much are they actually getting? So, and how much, their stomach is so small, how much can they actually digest and then, you know, get absorbed and processed throughout their entire body and nourish their whole body. So they have to eat in small bouts several times throughout the day. And while they're sleeping, we know that both prenatally but then newborns have huge amounts of REM cycles, REM sleep, and shorter non-REM cycles. So So you remember that from Psych 100, how we naturally cycle throughout the night. And they have all this REM sleep. And then waking up and eating, and then go back to sleep. And so you look at when the baby's asleep, their eyes are kind of darting back and forth, or they twitch and flutter, that you know then that they're in a REM cycle. And we know that REM sleep is directly correlated to brain development. So that's really important. So it's important they're getting nourishment and lots of good REM sleep. Right? So this is all happening while they're sleeping. They're creating these connections, synapses, getting things organized. Okay? So this process then of dendrite growth is called exuberance. Is that a term that you've heard before? Exuberance, or blooming. All right, so dendrite is Greek for tree. So kind of think of it as like a tree growing, and it's growing and growing and growing, and you've got all these branches, and they're kind of, if you've ever had a tree or a bush in your yard that gets all these extra branches, sometimes what happens is they'll get tangled, right? Or even one can kind of overtake another one, and then you wonder why you're not having any flowers blossom on your tree that spring. And so you've got then you have the guy from the nursery comes out and looks at your trees and says, oh, you need to prune these extra branches. There's too many branches. It can't get enough oxygen. It can't breathe. It can't properly grow. Which way do you want your tree to grow? Do you want it to grow up and out, or do you want it to grow lower and be fuller down here? You know what I'm talking about? So then they'll prune it. So they come and prune the branches. So this is what's happening in your developing brain. You've got all this massive exuberance going on, all this dendrite growth, which is a part of normal brain maturation, and you're getting all these connections, but then it gets all mixed up. There's too many signals, and it's not efficient. Or you're not getting, maybe you've had some normal exuberance just from brain maturation, but you're not getting any feedback. So if you're not going to get any feedback in a certain pathway, then the brain will naturally prune away the unused dendrites or the unneeded dendrites. So now all of a sudden you get a more efficient pathway, and it's just like this beautiful process that just happens both genetically from your inheritance of how your brain is supposed to mature, but then also through your experience determines exactly what pathways get pruned. So I mentioned last week at birth, newborns can hear every sound that comes from the human voice box, right? So you've got all of that proliferation, the exuberance has taken place. But if the infant is not exposed to certain sounds, they're not going to get feedback through their sensory neurons. They're not getting any input to their brain. So then that pathway, those dendrites will be pruned. What's really cool, also I just learned this, babies recognize monkey faces, also up to about 6 months old. So they could tell, babies know the difference between their mom's face, their dad's face, brother's face, grandma's face, stranger's face. And we know this because when the baby does something called habituating, when they look at a face that's new, they'll turn and look at it, and then when they get tired of it, they'll look away. So the scientist says, well, that means they know the face, they've become habituated to it. So that's how we study infants' perception, because we can't interview them. Do you know this face? Do you know? They can't really answer us. So we look at how long they gaze, how long they look at something, and then get bored and look away. So newborn babies can tell the difference between monkey faces, as if it were mom, dad, brother, sister. But because we don't live in the jungle, unless you're Tarzan and you're surrounded by a whole tribe of monkeys, you're not going to get that feedback. And so you're going to lose the ability to tell the difference between monkey faces, which I'm sure that you can't, right? I mean, maybe if you're a zookeeper and you raise a bunch of monkeys, you can tell the difference between them. But I think it's fascinating that it's all there because of that natural exuberance, but then anything that's not used just gets pruned or overtaken by more important pathways. So the mama, da, da, ba, ba that we hear all the time in so many languages and in the English language, those pathways get stronger and stronger, and then the auditory pathways that they aren't exposed to kind of get swallowed up, pruned, disappear. So this is called use it or lose it. So exuberance and pruning, you use it, you continue, you get those neurotransmitters keep getting produced and released, the synapse gets stronger and stronger. The more and more you do something or exposed to something, then you get more myelin on the axons to make it faster and faster, more automatic. And, bingo, just absolutely beautiful networks created. You don't use it, it withers up and dies. Okay? So we also call this experience expectant. Some things your brain are just pre-wired to expect to develop. We will develop language. It depends on what language we're exposed to determine which one develops. Right? What accent the child develops depends on what they're exposed to. But developing language is experience expectant as opposed to experience dependent. All right? Humans are not experience expectant to know how to swim, which I think is weird because so many animals just can instinctually swim, but humans can't. And I don't care what anybody tells you. I've taught swimming for 20 years. You can't just throw a child in the water. They will drown. Okay? It's not experience expectant. It's experience dependent. So depending on the exposure of how they are taught how to do that skill, yeah, their brain will figure it out. And the younger they are, the easier it'll be. But it's not like walking. Walking is experience expectant. It doesn't really have to be taught. You just have to give them the opportunities. They don't need a working model in their home. It's like a baby who's can hear but is being raised by deaf parents and doesn't have anybody really talking to her. She can hear, and it's experience expectant that she learn how to speak, but she'll have to have other models, right? But she will learn how to speak, and she will not have any kind of mispronunciation or anything like that. She will be able to do it, but she does need to have some of those working models. Okay. All right, let's watch this Science of Babies. Okay, so all of these experiences then that the baby develops are dependent on what environments they're exposed to. So, it's so sad when you see those babies in the orphanages that don't have human contact. They don't have a stimulating environment. More important than toys or objects or music and all these things that, we in our first world do to try to stimulate babies are really not very important. What's important is human faces, human contact, human interaction. So you don't need fancy toys and expensive things for your baby. You need a safe environment and interaction. And that's what's going to really develop the brain. Another good one to look at there's so many good programs that you can get on Netflix. There's one just called Babies, and it's a cross-cultural comparison of babies from all over the world. And it's fascinating because the babies really respond and react in the same exact way no matter what culture they're in. So there's a baby I think in China, an American baby or Australian baby, which we are similar, culture to Australians, and African. And the African babies, they're like exploring their world, crawling around, scooting around, and picking up rocks and kind of thumping the rocks on the ground, putting the rock in their mouth, a big rock, right? Putting the big rock in their mouth, licking it, putting it back down, scooting around, pulling up on their mom. I mean, it's no different than the American baby scooting around, picking up a rattle, shaking it, setting it back down, pulling up onto mom. I mean, their behavior is really identical, even though the environment and the cultural customs are quite different. And this is because we're all the same species. We're all humans, and we're all born with these basic reflexes, and then we just have this brain maturation that takes place. So the baby is born with built-in reactions to stimuli. It's there in the DNA. It's there ready to go, and it's for survival. So that's not too surprising that they have to be able to, breathe and respond to the environment appropriately so they get their needs met. So crying is a reflex when they need something. Blinking, sneezing. I mean, it's completely automatic and involuntary, but it's really all about survival. So we've also got things that have to do then with feeding. So the rooting reflex is when a baby's cheek is touched or stroked, they will turn towards it, and then they will open their mouth just like a baby bird, a real big open, and they're searching for the nipple. And then they have the sucking reflex, right? So mom can help out the baby in getting him positioned and finding the right way to latch on. If they're not latched onto the nipple correctly, then that can be painful for mom. Or if they're bottle fed, if there's too much air, that's one thing. Is the bottle might create more air and then gas for the baby. Then breastfeeding is less gassy. But those are all reflexes. So that's why you put a pacifier in the baby's mouth, and they will also reflexively suck. And a lot of the research has shown that the use of pacifiers in the first 6 months of life can be really beneficial. It does pacify. It soothes. You want to make sure that they're not really hungry, right? That you're not using it as a substitute for eating. And most babies will naturally outgrow it when they don't need it anymore, and they'll come up with other strategies for self-soothing. But that's all based on a reflex. The Moro or startle reflex, that one they're not really sure. It's where if they get a little bit thrown off balance, so say you're cradling a baby in your arms and you tip forward, say you were sitting down and you go to stand up and you're cradling them and they're asleep. Even in their sleep, their arms will flail out, and it's like they're trying to catch their balance. What is this really for? They're not entirely sure. It's something to do with equilibrium, but they already are able to feel that in their inner ear when they go off balance, and so then they're trying to kick it back, maybe. Yeah, Priscilla?
So what exactly is the point of the beach? Like, I know they give it to the child so they don't suck on their fingers, or...
Well, like I said, in the first 6 months of life, a pacifier it serves a couple of purposes. It does self-soothe. It keeps the airway open. They have shown it to be a protective factor against SIDS, sudden infant death syndrome. So you put the pacifier in, the baby can suck on that. What you don't want to do is to pacify your baby with your breast. And they're not really eating. And then they're using mom, or they're using a bottle to self-soothe to fall asleep, because now all of a sudden you've could possibly create a feeding problem or problem for mom, right? So they found that a lot of developmental psychologists and pediatricians will often agree that it can be a healthy thing to be teaching self-soothing skills so that they can get themselves to sleep without using mom to get to sleep, because it's calming, it's relaxing. It is meeting a need, right? And this is where we get to Freud. Freud said that's meeting a need. Oral stimulation is meeting a need. And you could see it in the baby. All of a sudden they're happy, they stop crying. But I think that connection that it does protect keeps the airway open. And then, often they fall asleep and spit it out, or you want to go, a lot of times the pediatrician will say, check, and, if they've spit it out, then remove it from the crib so they don't accidentally mush their face into it. Once they get kind of close to a year, you're kind of, if they haven't naturally done away with it, you want to sort of maybe start trying to steer towards other things, because it can then become a habit. By about 18 months, really, they don't really need it anymore. Just like they don't really need to be breastfed or bottle fed after 18 months. In our country, in a first world country that has access to good nutrition, if you're in a third world country and you don't have access to good nutrition, then breastfeeding a child longer is probably a good idea. But in our country, they're already eating solids. By 18 months, they really don't need formula or breast milk. Usually by then you've switched them to cow's milk. So, so the whole binky thing, then at that point, is a habit. It's a really great question. I would have to, just on my own gut and experience, think that the child who got rid of their binky at sort of the developmentally appropriate age by 18 months would be more likely to be well adjusted. And maybe we could when we're talking later this week, and I'll look online, you can look online. I'm thinking of things like temperament, and kids that have an easier temperament or a slow to warm up temperament. So like maybe a child who's slow to warm up is more resistant to change, wants to keep the binky for security, and we know that turns into a personality type. They're more sort of hesitant, resistant. I don't know, Camden didn't use the binky, but I've come to learn that he was a slow to warm up child, and still is kind of. He sits on the perimeter. He waits and watches. Now he's older, so he knows that he has, when they say everybody line up, he knows he's got to go line up. But you can see in his face that he's not real happy about it. Yeah, Kaylee? No, if they don't want the binky, that's fine. Yeah, like I said, Camden, he'd always spit it out, and he was a little bit harder to get to sleep. I had to rub his back longer. Quentin took the pacifier and was, but his temperament was just so easy. And I didn't know, when you have your first baby, you don't know. You have nothing to compare it to. And so we thought Camden was easy, because he would stop crying when I picked him up. And I hear other stories of other moms saying, oh, my baby cries for hours, even when I'm holding him. And I thought, in my mind, oh, well, my baby must be easy because when I pick him up, he stops crying. But I had to rock him all the way to sleep. So sometimes I'd be up for an hour, 45 minutes to an hour. And then I'd put him down, and I could only really leave the room if he was all the way asleep. Quentin, even at 6 weeks old, I could leave still awake. And sometimes even without the pacifier. So then I was like, this is what they mean in the textbook by easy baby. Camden was probably more typical. And now I've even come to appreciate he's probably a slow to warm up temperament. Not a nervous kid, but he's an introvert. He wants to watch and test out the new environment before he goes in and joins in with everybody else. Quentin's the center of attention. He just runs right into the middle, and I've seen that translate from infancy. Of course, we as the parents are going, oh, look, he's this way, and then we kind of pull that trait out in how we respond to them. So it's constantly an interaction between the environment and whatever their natural predisposition is. But no, if a baby doesn't take a pacifier, that's totally fine. That's okay. Don't worry about that. I would always want him to try to take it because I'd be like, I'm so tired. I want to go to bed. Take the pacifier. And, so you just figure out every kid's different, right? Every baby's different. Let's take a look at these. All right, so gross motor skills are movements coming from the large muscles. All right, so initially, we don't have a lot of motor movement, right? It's just basic reflexes. But eventually, by 2 years, the child is walking, running, climbing. Those are all gross motor skills. Jumping, and then it just keeps progressing from there. So from toddlerhood to the preschool years, they're gaining more coordination and skill, such as hopping and skipping, riding a bike. All of those things fall under gross motor skills. So in the first year of life, obviously, we're talking about crawling to pulling up to walking, standing and walking. Those are gross motor skills, and they are experience expectant. Okay? Whether they learn how to ride a bike depends on how much you pursue it. And these are just absolutely approximations of the developmental milestones for gross motor movements. Some people skip them. You know, some kids you'll go, gosh, I don't really remember them crawling too much. Or some won't crawl, they'll bear walk. They'll do this really funny like push-up. So they're laying on their belly, and they'll somehow they'll go get their rump up in the air and push up, and then they will bear walk. They're not down on their knees at all. And other kids almost kind of seem to skip and go straight to pulling up. Some of it might depend on how big they are, whether they can support themselves. One of my good friends has a daughter that was teeny tiny, and she walked at 9 months. And she was like super coordinated. It was crazy. We were at a wedding one time, and she was like 10 months old, and she was running across the dance floor. I've never seen an infant that small. It was the craziest thing. It almost looked like a movie, like it was fake. It was like this little thing running across. And she was just so tiny, she could support herself. Yeah, Kaylee?
What's like the average age for being potty trained?
Oh, average age depends on what culture you're in.
Well,
Our culture, about 3. Age 3 to 3.5. Yeah. But it depends. We'll get to that probably in maybe a little bit into next week. I'm not sure if I'll get to that this week. Yeah.
I know someone in her kids like 4.5 or so.
Yeah, that's late. 4.5 would be late. Yeah. Usually most preschools want the kids at age 3 to be like they're pretty rigorous at potty training. Kids that go to preschool versus stay at home tend to have an easier time at potty training because it's all the teachers work on it all day long. I'm like, yeah, you go to work. That's why I'm writing you a check, right? So, I mean, obviously reinforce it at home too. But yeah, you always got to ask the question, is there something physically wrong? You know, what's going on? Because most kids, if they mess their pants and they're 4.5 years old, they're going to not like that. Your body should have control.
It's like the little girl, she knows, and she'll like come up to you right away and say, oh, I need to be changed. But it's like, I think it's the mom, she just doesn't really want to, have to.
Do they still have her in pull-ups?
Yeah.
Well, that's the problem. They got to get rid of the pull-ups and put her in underwear, let her have a couple days of being wet and uncomfortable, and she'll stop.
The mom's a little
Yeah. So parents are pretty good at enabling things sometimes, you know. I mean, I think in my generation, a lot of us were still in cloth diapers. And my mom had me in cloth diapers, and I was potty trained really young. Cloth diapers, I can't even imagine. They probably felt terrible. So, they don't pull the moisture away from your skin at all. And, you just deal with the accidents. The thing is, if you start it too young, before they physically can control, like they absolutely, like they're the maturation of their organs, like they don't have the muscular control to hold it, then you're just kind of dragging the process out longer. So, people who try to potty train before age 2, I mean, it just might drag it out longer. So looking at this little diagram here, you can kind of see what the typical progression is for gross motor development. But it's really quite a range. Just look at, walking using furniture for support, a little over 7 months, all the way up to 13 months, and our sort of average age for walking, is about that 13 months. Okay, so, but it really it varies on the individual child, and what opportunities they're given, and then personality can go into it too. If they really, really want something, they may pull up sooner to try to get something. Fine motor skills then are your smaller muscle dexterity. So you're using your fingers, okay? And this is using a different group of muscles, a different neurological pathway, and it's harder for a baby to control their fine motor movements. So what do we give the baby to practice with their finger dexterity? Cheerios, right? Give them the Cheerios, and they practice, and they reach down to their tray, and they want those Cheerios, man, so they use their pincher grasp, and but they don't have a lot of control, but they are reaching and grasping. But fine motor skills continue to develop at a somewhat slow pace then throughout early childhood. So in the preschool, they will have, all of the crayons and the markers are fatter so that they're easier to grasp for the toddler, right? And then they'll give them scissors to practice cutting, but they're not going to be very good at it for quite a while. Some kids don't get good at those fine motor skills until 1st or 2nd grade. And fine motor skills often develop faster in girls than in boys. Maybe there's something different about the organization of the brain. Obviously, those boys are going to catch up. But I think just statistically, they do see a difference in that, and that's pretty normal. Camden had he actually had sort of a delayed fine motor development, not early on like this. He could grasp small objects and feed himself as a toddler, and he could grab the marker and scribble, and but then comes kindergarten. He had a really hard time learning how to write and control, and they brought in an occupational therapist to just observe him, and he had such light pressure on the pencil, and they tried giving him different little tricks and tips to help him, and but he wasn't so bad that he qualified for services. You have to be 2 standard deviations below the mean to even be assessed for special services, and they said, well, he's not bad enough yet. Okay, so what, we're going to wait until he gets really delayed? So I took it in my own hands and took him to occupational therapy. And so he went to occupational therapy all of 2nd grade, because 1st grade was still a struggle. And he'd get mad because he knew all the information up here in his head, and he couldn't get it down on the paper because he couldn't control the pencil. He literally couldn't control it. He'd be like, it would be slipping. He couldn't get pressure down, and he would just get so mad. And so we went to OT, and they did all sorts of interesting things, like even just like they had a climbing wall, and he would hang on the climbing wall with his fingertips, just try to strengthen his fingers. And then they did mazes, so he would be taking his pencil and try to trace, and he wasn't supposed to touch the lines. And that's still kind of hard for him. He can write today, he does fine. It's legible, but his handwriting's pretty bad. It's not the neatest looking handwriting. And he said, "Oh, Mom, pretty soon I'll be keyboarding everything anyway and it won't matter." I said, "Oh, geez, you're too smart." Okay. Because he's right, isn't he? I mean, you do need to know how to write, but it doesn't necessarily have to be perfect. Everybody kind of knows that, right? Okay, so sensation and perception then. You know, everything is there at birth, but not real acutely. So the sensory receptors are there. They can definitely feel, you know, on their skin. They can feel sensations. They have pain receptors. This idea that babies don't feel pain is absolutely ridiculous. Obviously, they feel pain. Obviously, they are having reactions to that. They can taste. You put that little droplet of water on their lips. If it's lemon water, they make a sour expression, you know, that with their lips and their face. If it's sweet, they'll lick and suck. If it's salty, they'll lick and suck. So we know that they can taste. You know, they can hear really well, pretty well. I mean, they can even recognize their mother's and their father's voice at birth. Because, and how, you know, you might say, well, how do they know that? Well, because they turn their head in the direction of mother when they hear her talking, when she comes in the room. They can't see very well. Their vision is pretty blurry, and from these different sensation and perception tests, they've discovered that babies respond the best to black and white and primary colors. So, you know, if you want to have like a enriched environment for your baby's nursery, these geometric shapes in black and white and using red and blue and yellow, like a bright primary color yellow, actually is probably what your baby can see. A light blue room or a pink room and a bunch of pastel toys, probably all is just kind of grayish to the baby. That's kind of a guess, but they really don't habituate to it. They don't really attend to looking at those objects. And I should probably get paid for endorsing this company, but the company Sassy Toys makes a lot of toys using black and white stripes and geometrical patterns and primary colors. Does anybody know the Sassy Toys? Yeah, and so if you ever get invited to a baby shower, buy something like that, and you know, then after the baby's born, mom will say, "That's his favorite rattle," and it's because they can see it. So, how do we study the infant's perception? They use this thing called the orienting response, or the visual preference method. So they look for the baby to habituate to the object or the face. So the baby, they show an object or they show a face. The baby notices it. Okay, so can they orient to it? Can they notice it? Do they focus on it? Do they look at it? Okay, so that's first, you know, orienting. And then how long do they stare at it before they get bored and look away? And so once they get bored and look away, we say they've habituated to it. So now you saw in that video, they can actually do some of this with putting on the little cap to look at their brain activity, to see what they're finding interesting. But a lot of scientists are absolutely just watching the baby's reaction. And this is a picture from, I think, probably the 1950s or 60s. You've got the baby lying on their mattress down here, and they're looking at different objects and colors. And the scientist is looking down and watching the baby's gaze and timing how long they look at it before first they check to see that they orient to the new object or the new design, and then they count how many seconds they stare at it before their eyes glance away. Can you imagine being that kind of researcher? I took, and I think I already apologized about talking about my kids a lot, but so I'll apologize one more time. I took Camden to a research study because I thought, oh, here I'm going to contribute to science. So I got recruited. I can't remember how I got recruited. Oh, I think it was just from the hospital records. They sent from the hospital. They sent out postcards saying, "Would you please have your child be part of this study?" And so it was a language study. So I was kind of curious since I was, studying development at the time, and so it was at BU. And I took Camden in, and I know he wasn't sitting up yet, so he must have been 5 or 6 months old is all. So he was sitting on my lap, and they would have a little object. So we were in a kind of a darkened room. He's sitting on my lap, and then the researcher would go into this other room, and then a little object like a puppet would pop up, and he would look at it, and then they would play a recording of a sentence, like, Jimmy rode his bike across the street, and they would just keep repeating that, and then they'd have like another little toy object come up, and this researcher was watching through a screen, and they were videotaping it, and they were watching to see if Camden would look, and they would flash a light, and he'd have to turn his head and look, and then when a new word, would he orient it to a new word, or get how long was he being habituated to that word? But they were using the objects, the little toy. I remember the one was freaky. It popped up, and it was one of those monkeys with the cymbals. You know what I'm talking about? Like from Toy Story, the scary monkey. It didn't make that sound, but it just did the cymbal. So that gets his attention. He's 5 months old. So he looks, he orients. The little monkey would, got him to look up, and then they would play the recording of the sentence. It was very labor intensive for, I imagine, the researcher, and then also for me, because then he started squirming around on my lap. But I did it. I stuck it out. I finished the study, and they were very grateful, and they gave me a free coffee mug. I was like, really? That's my prize? Free coffee mug. Okay. It said BU on it. Cool, whatever. Okay, so we already watched the video clip of preference for human faces over the monkey faces. So they absolutely understand at first, early, the first couple of months, they will respond to a messed up face, right? So the eyes are down at the bottom, the eyes are sideways. It doesn't really matter. They will orient to it. Once they hit, a few months old, they only really want to orient to the face in the right direction. The two eyes at the top, something in the center, and then a mouth kind of at the bottom. And they have this preference for looking at human faces. And you saw on that last slide, go back a second, that's what takes the longest for them to habituate to. It's more interesting. So it makes you go, okay, there's something about humans that we're pre-wired, we're like hungry for human interaction. It's more interesting and stimulating than solid colors. This starts to look more interesting, but it still doesn't have like that face pattern. And so babies have a preference then for human faces. And they also are figuring out depth perception. So initially, they don't have depth perception. We have two eyes, and two eyes are used as binocular vision so that we can understand distance and depth. If you only had one working eye, everything would kind of be flat. It would take time for your brain. Like if you guys had an eye injury and had to have one eye patched up, initially within that first day, you're not going to have a depth perception. So you're going to have difficulty knowing how far, like driving would be maybe. You shouldn't drive, right? But I remember that happened to me one time. I had a corneal abrasion. My eye got scratched, and so I went to the eye doctor, and he flushed it out, cleaned it out, and then he patched my eye. And so I left the doctor's office, and I go to push the button for the elevator, and I completely missed. I'm like trying to hit the elevator button, and my depth perception was totally off. And gosh, I think maybe I did drive. But I was like freaking out because I had no depth perception. So a newborn doesn't have that coordination between the eyes yet, and that takes time. And so we have this classic study called the visual cliff, where they have a baby on a table, up on a table with a pattern. There's like a checkerboard pattern across the table. But that last half of the table, it's actually a clear plexiglass. But then the pattern continues down on the floor. So it gives you a perception of a drop-off. You think that there's a cliff and a drop-off. So the researchers were interested in seeing at what age does the child notice that this drops off. Will they just continue to try to go across it? And what they find is the early crawlers, they say, okay, well, depth perception seems to happen at about 3 to 4 months of age. Well, most babies aren't crawling that soon. So they do this visual cliff test, and those who have just started crawling, they get up to the edge, and they look down, and they don't. It's like almost like they don't notice it, and they'll just keep walking across. They'll keep crawling across. The older babies who've been crawling longer, so like 8, 9 month old, they'll stop and they like won't go. So the best guess is that they've had more experience crawling, and maybe they've had some tumbles. Maybe they've fallen. They've had some experience in what happens if you go down something too steep. You know, does the child have fear? You know, I mean, it's hard to say if they have fear, but it's just funny watching these. You can look at them on YouTube, and they won't cross until they get lots and lots of coaxing from mom at the other end, and then they realize, and they kind of test it out and tap the plexiglass, and they can crawl across. So they've kind of used the visual cliff experiment for more things other than just depth perception. They've used it to try to figure out, is this something like maybe fear response that's happening around that same time because of experience. Okay, so continued brain development obviously is going to have changes in their cognitive development. So our main focus here in looking at cognitive development is Jean Piaget and his sensory motor stage. Look a little bit at conditioning, and then I don't know if we'll get to attention, memory, and concept formation or language development, but I definitely want to go through Piaget here. So remember, Piaget's theory was, we were really looking at a stage theory where each developmental stage is qualitatively different. So it's a discontinuous type of development in his theory. Yeah, it is building, obviously, through experience, but there is a cognitive switch when they jump from one stage to the next. And he called this first stage sensory motor intelligence because the child's thinking, the baby's thinking is not, very mature yet. So they basically have those basic reflexes and those senses that are coming in. They've got that input information into their brain, and things happen at first by accident because of reflexes, and then through experience it becomes more and more intentional, right? So they're using their senses and then their reflexive motor skills that then get more fine-tuned, and it's causing changes in their brain because then they go, I understand what this toy is here. When I reach for it and grab it, it makes a noise when I shake it. So it starts off as a reflex. They accidentally found the toy, right? And then over time and more experience, they come to realize that they want that toy, and they reach for it, they grab it, and then they shake it. Does this make a noise? Okay. I'm going to actually skip the video clip. I think I have it on Canvas, the video clip of Piaget. So let's first just talk about what Piaget meant by creating mental concepts or mental structures in order to organize one's world. So in every stage of development, in his entire theory of cognitive development, we go through this process of concept formation. What we're doing is we're developing schemes or schemas. Kind of depends on the translation that you're reading, whether you read schemes or schemas. It means the same thing. It's essentially your set of ideas about a particular scenario or concept, right? So we have pretty limited concepts early on, and it's only through linking together ideas in time and space to create new concepts or new schemes or schemas. Okay? He said this process of acquiring new information and adapting new thought processes is called assimilation and accommodation. So you have some idea about a certain concept, and when you're exposed to something new that you've never seen before or heard before, we tend to assimilate that information to something we already know. And so you may make mistakes then in your judgment of this new thing because you're just incorporating it with your current set of ideas, your current schema, okay, your previous knowledge. Then, as you're figuring out, wait a second, this is something new, this is different, you create a new category and you accommodate this new information into a new schema. You expand it or adjust it. So as you're going through this process of assimilation and accommodation, you have sort of a disequilibrium or lack of understanding of what's going on. And it's that shift of accommodation that he called equilibration, it's hard to say, or what I like to just simply say, the light bulb moment. You shift your thinking, you go, oh, okay. So the little kid sees they have a pet cat, and they know the word kitty. And they see the kitty walking around on 4 legs, and it's small and low to the ground, and it's covered in fur. And then you go to the neighbor's house, and they have a small dog that's got 4 legs, low to the ground, covered in fur. And the little toddler, the 2-year-old, goes, kitty. Okay? They're assimilating what they already know. They already know the word kitty and the idea, the schema, the concept of kitty. And then, mom and dad will say, oh, this is a dog. But, good, yeah, it's soft, it kind of looks like our kitty, but and then maybe the dog will bark. And so the child is learning through their past experiences, making an assimilation between similar concepts, schemas for this small animal, right? But then there's a shift that takes place. They begin to understand, oh, there's other small animals covered in fur that walk around on 4 legs. But this kind that barks is called a dog, and it's different. So then they reach equilibration, and they've accommodated, and it's the light bulb moment. They have a new category of animal. And kids do this instantly, right? Other things take longer, but we learn this way as well, through assimilation and accommodation. So that moment of disequilibrium is when you're in conflict, where you don't quite understand yet what this new bit of information coming in is. And so you don't quite know what to do with it. So the only thing you really can do is assimilate it. And then as you're getting more information, so either you're seeking it out through asking questions, or, adults or more expert kids are giving you this information and talking about it and telling you about it, or you're just simply in these environments and you're acquiring more and more information, but you have this kind of internal search to try to figure it out. And so Piaget said that's what makes the child an explorer. They're constantly trying to figure out, what are these things? What's this? What's this? This seems kind of familiar, but it's not quite right. I don't quite get it. And they test it out, and then they figure it out. They make an accommodation, and they go, oh yeah, and they have a new concept, a new category of thinking. And that's why he said it was qualitatively different. It's a shift. You all of a sudden you go, okay, I get it. I understand. Okay, so let's talk about what's happening in these sensory motor stages then. So if an infant can only construct their understanding through their senses and through their reflexes, that means that initially learning is by accident. It's kind of a trial and error accident. And then next thing you know, it becomes more of a habit, and then the habit turns into intentional change, and then eventually curiosity. So he breaks it down into all these sub-stages. So I like to give the example of that baby he's laying on his little play mat on his back, and there's a mobile that goes kind of reaches across him. And the little toys, the dealy bobs, are hanging down, and he's kicking his legs, swinging his arms, reflexively, right, and kicks one on accident, or bats one with his hand on accident. And it bounces, right? It's on a little sort of, maybe it's on a spongy spring coil, like fabric coil. Do you know what I'm talking about? If you don't have babies or haven't babysat, you might not know what I'm talking about. I should have brought one. I've gotten rid of all that type of stuff, though, actually. So there's a reaction that happens by accident from the simple reflex. So the first habits, then, are a result of he has something happen, and it's interesting, it's exciting. He's going to orient to that change. The mobile's now moving. And so then his reaction might be excitement. So then he'll sort of reflexively flail his arms out, and, get excited, and then he'll hit it again on accident. And as this happens more and more, and of course we've got brain development going on, realize, I did that. And then he's going to try to reach for it. Doesn't have good control of his arms and legs yet, but then maybe he gets it, and actually the grasping reflex, and pulls, and the whole thing bounces as he's pulling it down, and the whole mobile's bouncing. He's getting really excited. Okay, so he's coordinating these secondary circular reactions. And then he goes, okay, I know that this thing bounces if I'm able to grab hold of it. And so then maybe he's in a new environment. Maybe he's at the daycare center now. And they have a similar toy, but it's a little bit different. He's going to probably test it out in the same way as the toy at home. So maybe he has figured out some rattles at home. And again, that's been by accident. So you've got these rattles kind of around the play mat. The baby accidentally grasps one just by chance, and then gets excited, shakes, the thing makes noise, and goes, oh, this is so cool, I love this. And then they stick it in their mouth, and oh, I really like this. Then they go to a daycare or grandma's house, and there's a different toy. Maybe there's a stuffed animal, and they grab it, pick it up. What are they going to do with that stuffed animal? Shake it. Oh, why doesn't this make noise? My thing at home makes noise when I shake it. So they're assimilating toy, fun, right? Whatever those simple processes that are going on in their brain. It's just feedback, right? They're getting feedback. Okay. Oh, let me try it in my mouth. They put it in their mouth. Okay, well, that's not food, and I can't suck on it, but I like the way that feels on my face. It's hard to know exactly what they're thinking, but they will then get a sense of curiosity and test things out. So the lab in a university that has sort of a baby lab or a toddler preschool lab, and they have all the toys. Those are all new toys to those babies, toddlers, preschoolers. And they're going to first test them out and play with them in the way that they know and understand from their past experience. And then if it's something new, they'll accommodate and they'll create these schemas based on those experiences then. Okay. So I have a little handout that we can use to practice this. Another term from Piaget was object permanence. And object permanence is essentially understanding that something still exists even though it's hidden. A young baby, if you hide an object, the young baby, they think that it doesn't exist anymore. They cease to understand, it's gone. It's out of their vision, so they immediately, are uninterested, forget about it. They're not going to go look for the object. So peekaboo in a child less than a year old can be kind of fun because it's like, she's gone, she's back. She's gone, she's back. Once they get to be, closer to a year, they will start to understand that something exists even though it's hidden. So they do this classic thing called the A, not B task. And you show the baby the keys, you hide it under a blanket, and then they pull the blanket off, and it's great fun because, haha, you tried to trick me, but there it is. It's under the object. The younger baby won't try to look for it because it's gone. They don't understand. They don't. It's just simply gone. Yeah.
Not for someone
With an older child.
Because I know someone I was friends with both their parents, and the dad died when the kid was 7 months, and the kid would still crawl around saying dad.
Oh, well, having somebody dying and then continuing to look for them, that's a much more abstract, more difficult to understand concept. So that's going to take a lot more, development in understanding. Death's hard for anybody to understand, right? But can you imagine for a kid, for a baby? It's going to be incredibly hard to understand. But the object, that's simply about perspective taking and mental concepts and this idea of something continuing to exist even though it's just out of sight. So they're not very, and it gets kind of into, it's sort of funny, at about 12 months, they'll look for the object and they'll pull it off, but then if you do the A not B task, you first did it under blanket A, and they find it joyously, and then the second time you put it under, and then you take it out, and then you put it under blanket B, they will go back to, they will still pick up from blanket A. They don't get quite that, they don't have that cognitive shift yet in that you moved the object, and that will come later. A 1-year-old can't find something right away in their first, so that's again assimilating. In the first place that they first found something, they'll kind of stop looking. It's not until they're 2 or 3 years old maybe that they start to continue to look. But this is probably also why toddlers and preschoolers are really terrible at hide and seek, because they'll hide their eyes. And that gets into preschoolers and egocentric thinking, which is another concept from Piaget. Well, I can't see you, so you can't see me. So their thinking is not mature enough yet to quite understand this whole notion of hiding things. But object permanence, we can definitely do a test for that, and it's pretty fascinating. They all respond the same. It's still a window of development of when they're going to understand something continues to exist. It's like if they drop something off of their high chair, do they look down to look for it? And if they don't see it immediately, then they instantly become either distressed or disinterested. It's gone, and then depending on how the caregiver responds, it's going to continue to shape their response, right? So, like I said, this kind of gets into operant conditioning and how babies learn. Roe v. Collier did this classic study of the baby mobile. So they tie a ribbon around the baby's ankle, and so that makes the mobile move when she reflexively bounces her leg. And she would do this, condition her several days over the course of, a couple weeks. But then they stopped doing it. The baby kept trying to kick her leg. And so she's not getting a reaction. So we'd say that there's no secondary or tertiary reaction because she can't reach the mobile. So she stops kicking her leg with any kind of intention. So researcher says, oh, well, she's forgotten. Well, Carolyn Roe v. Collier, 6 months later, after the training there's been no training going on, they tie a ribbon around the baby's ankle again. So now she's a little bit older. She's maybe 9 months old. So this is a 3-month-old. They tie the ribbon. The baby does it instantly. Sees that ribbon, makes the connection. So this is what the theory is saying is babies have memory. And she remembered it instantly. She did the skill. She kicked her leg to watch the mobile bounce. Right? Yeah. Usually object permanence doesn't happen until, so this is 3 months, so they don't have object permanence.
So object permanence then probably would be related to memory directly?
Not directly. It's kind of a higher level function. I mean, cognitively, when you think about the idea of something still existing even though you can't see it, this is really conditioning a skill with a clear reaction that she's seeing. But I think what was important about this study from 1987 was prior to that time, they thought because of infantile amnesia and childhood amnesia, they didn't think that babies were forming memories. But clearly they are. Obviously, this is how they learn, and this is a very easy way that we could teach something and then test for it. And they have a memory. Now, are we going to, when this child is 5 years old and we interview them, do you remember when you had that ribbon tied to your ankle? They're going to say no, they don't have that kind of. So there is infantile amnesia, and we're not really sure why, except for that it's probably not necessarily because they've accommodated and moved on to higher level functions and higher level thinking. It's not important to remember that you had a ribbon tied to your ankle, Obviously, stronger memories, usually people's first memories have really strong associations with them emotionally. Either you got hurt, you remember getting hurt, or it could be a very happy moment, right? Okay, so by 4 months, babies can have that selective attention to look at the object, and then habituation can take place. And that's what we want to see. We want to see that happening around 4 months. When the baby is taken into the pediatrician for that well visit, there's all sorts of things that the RN and the pediatrician in particular, sometimes the medical assistant, nowadays it almost seems like you get seen by a medical assistant more than an RN. I don't know, even the shots are given by the medical assistant. But the pediatrician comes in and they're talking to you and they're looking at the baby, and if you don't really know much about infant development, you might think all they're doing is weighing and measuring them and listening to their heart and their lungs. But they're doing all sorts of other tests as well. They're testing to see if the baby is focusing, is having attention. This is something that in the world of psychology, we are really happy that it's gotten really integrated into the medical world, that they are checking for normal cognitive development because it branches right into social and emotional development. If this baby, for whatever reason, 4 months, now they're 6 months old, and they're not focusing on objects or they're not attending to something, we have to wonder what's going on in their brain maturation? Why aren't they attending to objects? What might this mean? By 10 to 11 months old, they should also be engaging in what's called joint attention. So, you know, you've got your baby at that age is definitely should be sitting up, maybe crawling, maybe even pulling up and standing. So they're exploring their world. They're looking at all sorts of different objects. Maybe you're out at the park, and an airplane goes overhead, and you look up and you point and you go, look, an airplane. And the 10 or 11-month-old will look up. They'll see what they won't look at your finger. They'll understand. They just naturally understand that you're pointing up at something. They see this new thing or this interesting thing, and we have joint attention. We're sharing a moment, and it's actually social. You know, these are teaching moments and shared experiences, but we're having joint attention. And it's also the precursors to communication. So a baby doesn't have language yet, or very, very limited. You know, 10, 11-month-old is still babbling. They don't have usually have very many words at all, if maybe any at all. But they can use the vocalizations, and they can use their attentional processes. So if they want something, they'll reach and point at the object, and then if I want you to get something for me, and I'm pointing at this, then I'm going to look at you, right? If I don't have language yet, I'm going to point at the object, I'm going to look at you, and look back at the object. I'm telling you, get me that object. And so the doctor may be testing for these, or you as, and it's so natural that we don't really kind of realize that this is even happening. But it's a precursor towards communication and towards social interaction. Okay, I already talked about that. I want to talk about our topic just really, really briefly before I let you go, because we're sort of talking about two different topics. We've got the whole immunization controversy, but then we're also talking about autism. And, you know, what do you think causes autism? I'll tell you right here and now, no one knows definitively what causes autism. We have a lot of research pointing to, you know, different possibilities, but we don't really know. And so I can tell you that straight off the bat. There's no real right or wrong answer in answering that, but you have a lot of different resources that you can access to get an informed opinion. And then where does immunization follow in here? I mean, a lot of you are pre-nursing or pre-medicine majors. I might guess that you are pro-vaccine. I don't know. But the thing is, even when we're looking at this issue with autism, there's a lot of people that aren't getting their kids vaccinated. So even if you are, you know, you're pro-vaccine, I want you to think about why other people aren't. And then vice versa, if you aren't, if you don't want kids to be vaccinated, then really, really get rid of all your old thinking and really try to have an honest search of these materials to ask yourself what are the benefits. So you're watching this video, which some students in the past have told me is biased. Well, sure, almost anything is biased. So it's got a voice, a perspective in there. They try to show the different sides, but it's not that old. It's 2010. However, a lot has come out in the media since then, and I put up that little clip from Andrew Wakefield and how he's still scrambling and kind of interesting. But before you go, I want to define ASD. Okay, autism spectrum disorder has changed in the DSM in 2013, just this past year. So some of the things that you're reading are going to talk about, you might see pervasive developmental disorder, you might see Asperger's syndrome. Those different subcategories have been eliminated in the DSM-5. Autism spectrum disorders, they encompasses all of them now. And there's a lot of different reasons to that, and I won't get into it. Some of it's political, some of it's just simply to code it so that you get insurance covered. But it's a social communication disorder. It's a neurodevelopmental disorder. And to be diagnosed with an autism spectrum disorder, you have to have deficits in all 3 areas of the social communication impairments. So there's either a delay or a lack of social emotional reciprocity. So there's a give and take in, maybe how you're sharing experiences. So maybe the child does not have joint attention, like the looking at the object, and then, so that's a real simple test that they'll give to the child, and they want an object, and instead of making eye contact and looking up at the adult to get me the object, they'll just cry and scream, or they'll grab the adult's hand and use the hand like an object, instead of doing that sort of natural thing of looking up at the adult and back down. So that gets into the nonverbal communicative behaviors that aren't there. So eye contact, they don't respond maybe to their name at the developmentally appropriate age. And then difficulty understanding relationships. So they have to have deficits in all 3 areas. For the restricted and repetitive behaviors, they only have to have deficits in 2 of these 4 areas, but stereotyped or repetitive behaviors would be things like arm flapping or tiptoeing, lining stuff up, being really particular about their stuff. And that kind of gets into insistence on sameness, same routines, same foods that they eat, fixated interests. They can get really fascinated in a single topic, Thomas the Tank Engine, and be so fixated on it and nothing else, and talk about it for hours or look at it or play with it for hours. But then it also can branch onto things that regular developing kids or typical developing kids wouldn't find interesting, like a spinning light. And they become fixated with this spinning fan light or something, or even something like that's not even a toy, right? And then sensory interests or aversions. So they either want to touch everything, or they don't want, they can't stand having things touch their skin, or it could translate to aversions like on certain foods or textures. There's a real variety of different things. And so you have to have at least 2 of the 4. And typical onset that we start seeing, really clearly seeing some developmental delays in ASD is about 18 months. But most kids aren't actually diagnosed until they're closer to 3 or 4 even. All right, so I'll stop there.